Engineer Mohammed Wasif Laeeq. May I please kindly request him to come on stage?
Assalamu alaikum, and thank you so much for inviting me to share my ideas. The work I was working on a new technology, and I worked around 1 month, but still I feel that this time is not sufficient to complete that very innovative idea. So inshallah in the next presentation I will present that paper, and that would be a fantastic paper, I believe. Okay, so my topic is really relevant because nowadays this is the need of the time. Smart microgrid and BESS, building blocks of the autonomous grid. Actually, if we see what is the biggest problem nowadays that we are facing. So we see that the biggest problem nowadays is the energy crisis, and we can mitigate it by reducing the cost of energy mix, which we can only do by increasing or by inducting more and more renewable energy sources. If you want to add more renewable energy sources, so you have to improve your microgrid, and you have to take the full capacity of BESS. So because these two are the heroes to make, because the ultimate achievement of a microgrid and a BESS combination is an autonomous grid, because maybe that it is not a complete autonomous grid, but if it is most of the time autonomous, it can save you a lot of money, and it can reduce your energy mix considerably. So my focus in this presentation is on autonomous microgrid. I don't think that the people can read the complete thing, but I will try my level best that I will way to understand every slide. Okay, smart grid basically there are basically three main things. One is the load, second is the BESS, and the third are the DER, distributed energy sources. So microgrid is the brain connecting, optimizing all these three important groups. And load is the king, because in all these things, because we do everything for the load. So load is the king. Keeping this in mind, we will move forward. Okay, these are the main components like BESS, renewable energy sources, controllers, converters, and load. And load we can define critical, essential, non-essential, so, and microgrids, SCADAs, PLCs, and then grid synchronization, protection relays. So these are the main building blocks of smart microgrid. Okay, let's focus on autonomous grid. What is an autonomous grid? According to the definition, an autonomous grid is a self-sufficient power network that can operate independently without relying on a central utility grid. Okay. But this is the maximum thing, but as I have mentioned earlier, that even if you are using 50% of the time grid as an autonomous grid, you would be saving a lot. So our focus is to make it autonomous most of the time, if not all the time. Okay. So for making a robust autonomous grid, we require two things. Number one is the grid forming, and second is the black start. So grid form, black start, you can say that it is the continuation of grid forming. Okay. Let me explain you briefly that what is grid forming. Actually, we all know. Actually, I request your attention because like this, I think that this is very informative session. I put my heart and soul together, So I request your time, and I will, try to, conclude it within, 20 to 25 minutes, not more than that. Okay, so every renewable, things require a reference voltage and a reference frequency. So if we take it from the, like we can take it from a generator, we can take it from from any source. So if we provide this reference from BESS, then we say that it is grid forming, because if BESS is providing reference signal, we can avoid anti-islanding mode from wind, from solar, so we can utilize their energy. But without reference power, wind and solar cannot work if they are grid tied. So grid forming is very essential. And black start when your system is blackout and you have to start your system from scratch. This process is called black start. Black start is relatively easy, but grid forming is technically slightly difficult. Okay. So to explain you in detail, I have drawn one graph. Seeing this from here, I can say that my handwriting is very bad. I'm really sorry for that. This is a hand driven, but I will try my level best to explain you. Okay, there are two regions. This region is grid following, and this region is grid forming. What is grid forming? Suppose we are having a grid, and all the renewable energy sources taking reference from the grid. BESS is also taking reference from the grid. We say that it is grid following. Everything is grid following. Okay? This is an example. We say that this is a snapshot. Okay? At this snapshot moment, we see that the load is 10 megawatt and renewable energy like BESS is having capacity of 11 megawatt at this time, okay? Because available renewable means the energy that we are receiving from renewable at that point of time was 11 megawatt. I have shown 11 megawatt with a straight line because it is for a very very snapshot for a very short time, in a millisecond. In a millisecond, a curve can be a straight line. So this is a straight line. Now see that before having a fault, a vector shift from the grid, everything was smooth, calm and quiet. BESS was, like grid following, and since the load was below the renewable energy, so load was having all the things from renewable energy, all the energy from renewable. So the grid was only supplying a minimal power just to make it just to provide a voltage and frequency as a reference, and BESS was only running with the 1% or 2%. Okay, but all of a sudden, at this point there was a vector shift and grid gone. So within no time, like just in few milliseconds, the battery take up the load, and since I have told you that the load is the king, so the load line is straight, but the renewable, since renewable lost the reference voltage and frequency, so renewable stop giving power. What happens if BESS, since the BESS was having sufficient capacity, BESS was having sufficient SOC, okay? State of charge was, because the BESS may have capacity but it was not fully charged. So in that case, microgrid will do the load shedding. So it will reduce the load to match the load with the BESS capacity. So the main point to consider that when you are doing grid forming, like for a very short time, momentarily, the whole load would be borne by your BESS. So the BESS sizing is very important here. And BESS SOC, state of charge, is very important. So this is the responsibility of microgrid, to keep the battery charged as much as possible when grid forming is anticipated.
Wasif, you have 5 minutes left.
Sorry?
5 minutes left.
No. I have to complete it. If the people are ready, I will hear.
Yes, please. Yes, not ready.
Because, sorry?
You have to finish on time.
Sir, because this is very important topic, and like, if I want to explain.
Slotted time after the time.
Okay. Sorry?
Fixed slots.
Okay. Right. So we see that like BESS took the complete load, and the next thing the BESS will start to do, that BESS will maintain, stabilize voltage and frequency, and it will start synchronize with other DER, distributed energy sources, like maybe solar and wind or anything. So after that, we see that renewable, that starts, that green line is renewable. From this point, the renewable start increasing and the battery start decreasing its load. It's a handshaking, and slowly and gradually load start getting power from renewable, and battery return back to its initial position. So in this whole process, we have taken 180 millisecond time, which is known as CCT. CCT is basically critical connection time. Critical connection time is the time from grid following to grid forming. So this is very critical. So we have to do everything within this time. If our battery is not able to do this, or if our microgrid is not able to provide the signal within its speculated time, then this whole process cannot be achieved. So this process is very critical for an autonomous grid or for a robust grid. If I am saying robust grid, I mean that grid will avoid blackouts, because blackout is loss, and blackout is very dangerous sometimes. So this is very important, and things to be noted, like critical things that we have to see here, that here the battery has to react very fast on getting signal from microgrid. So microgrid signaling is very important, although like Goose protocol is very famous. Goose protocol is very fast, but I would prefer a hardwired signal, because the hardwire can transfer signal less than 5 milliseconds. So it is better that the signal should be notified from controller to BESS through hardwire. Second thing is that the battery, if the battery doesn't have the capacity, sufficient capacity, it is better that you go from 1C to 2C. If you are having 2C, so the battery can double the power for half the time. For example, if you are having 4 megawatt hour battery, it will give you 4 megawatt for 1 hour. But if it is 2C, it can give you 8 megawatt for half an hour. So for such cases, 2C or multiple C is ideal, because it can, for a very short time, it is, like it is able to give you more power, multiple C. Here, so these are, critical things. I have a lot to, mention over here, but time, 20 minutes is very short time, I, realized today. So, what should I do, because I think I don't have much time, but let me tell you black start also, if you give me 2 minutes. Okay, black start. What is black start? Actually, what is critical in black start, for example, if you are having a system with no power, everything is blackout, so your BESS has to, start the whole system. So very important thing, very critical thing in black start is, like in, algorithm forming, timing was very important. But in black start, the most important thing is the sizing, because you have to bear the inrush current, because inductive load can provide you 5 to 6 times inrush current. So battery starts, like with, ramping up the voltage. So initially the voltage level is low, then it keeps on increasing the voltage. In this way, you keep the inrush current in limit, because, BESS are good. PCS also have, like what I should say, a limiter, current limiter that can keep the, current in limit. But if it is increasing from the limit, then battery has no option but to, trip it on overcurrent, signal. So the most important thing and the procedure is that first battery energizes the black bus, and then the critical load is, receive the power, and then the renewable sources start having, like, synchronization with the voltage and frequency stabilized by our BESS. And in this way, BESS is doing the same thing that BESS was doing for the grid forming. So initially black start, and I am leaving my, rest of the, slides here. But I think that I have mentioned 2 most critical things of a robust autonomous grid. Thank you so much.